Welcome everybody. We are going to do linear algebra for gaming today. It's something I've been promising y'all for a while, and today is the day when it is now too late to drop the class. Okay. So in any 3D video game, you have to understand linear algebra. All right. It's normally offered as the last math class of a lot of colleges, and so a lot of people think that it thus must be the most advanced and the hardest one. It's not. Linear algebra is easy and fun, and there's a lot of neat things you can do with it. When you understand linear algebra, that unlocks the ability for you to make 3D video games. Like, until you do, like, maybe you can just copy my things where you're like, okay, we'll do this, and then feed it into like a vector length, and feed that into like a dot product or something. But once you kind of understand the mechanics of linear algebra and how they work and what they're useful for, then all of a sudden it's like a toolbox, and like you're making a video game, and you want to have your pedestrians jump out of the way of a car. How do you do it? You got a car, and a car has got a position. Everything's got a position. Everything's got a velocity, right? You got a pedestrian, like maybe over here. How does this AI react? Right? Can it see you? If it's looking the other way, maybe it doesn't see you. Maybe it can hear you when it gets really close. How does it react? How do you program this behavior? This is a very common behavior. Have you guys ever played a game in which pedestrians jump out of the way of a car? I've played at least 3 or 4. Yeah. Can you name any of them? And I can tell you one that they implemented it very badly. It was a AAA title by a company that made the Witcher series. Anyone know what game I'm talking about? Came out last. Saints Row, GTA, Cyberpunk. There we go. So what they did in Cyberpunk is they did a circle around the pedestrian, and if you had a motorcycle or something nearby, then the person would cower, and they would go on the ground like this and go, ah, and they would just move their head back and forth and just cower, ah, 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 and it was super annoying because, like, you can put your motorcycle on a sidewalk, and immediately just people start screaming, ah, and cowering, and you're like, I'm just pushing it with my foot, and people are like, screaming, and it was just a really, really badly designed pedestrian system. And so maybe if they had taken this class, they could have done it better. So how would you design it? And Cyberpunk is broken, yeah, and also like all the AI panic all at the same time. So you have the synchronized crowd of people all crouching, all moving their heads, all at the same time. It was so bad. I like Cyberpunk 2077. I 100%ed it, in fact, but there were some parts of the game that it was just like, maybe if they'd taken this class, they would have been able to make a better pedestrian avoidance system. So how would you do it? How would you got a pedestrian, you got a car, how would you do it? The pedestrian's got a position too. So that's the position of the pedestrian. We got the position of the car. We got the velocity of the car. We got no velocity of the pedestrian's presumably stationary, or not moving very fast to matter. How do we do this? And if you don't know linear algebra, it could be, Cyberpunk 2077. Are they close to me? If so, scream. But if you know linear algebra, then I'll show you how to do this in a little bit. But let's talk about the basics first. So this will be our goal for today, right? Our goal is to build a pedestrian avoidance system, right? Where you're coming at a pedestrian, they'll leap out of the way. Like in Grand Theft Auto, they'll do this, like they'll throw themselves sideways, right? You know what I'm talking about? They'll dive out of the way. You guys have all seen that? And away from the car, not towards the car. But not like this way either. Like away from the car would actually be like Just, and then you run them over anyway. So they move laterally. They move to the side. And they move to the side that is not going to get them run over. They don't go that way, So that's linear algebra. That's our goal for today. Yeah, driving on sidewalks, exactly. And so people will fling themselves out of the way, and then they'll yell at you, usually. Okay, so let's start with the basics. So we got points. And so if we are in 3D space, typically has vector 3s, is typically what we have in 3D space, because you got an X, you got a Y, and you got a Z. And so we'll write it out like this, terminology-wise. X, Y, and Z. That's how we write it. And so a vector can represent a position. For example, if the position is 10, 20, 30, we'd write the position of 10, 20, 30. So this could be like the position of the car. What do we call it? P1. Position 1. Say position 1 is at X is equal to, this is basically X is equal to 10, Y is equal to 20, Z is equal to 30, right? And then the position of the player, position 2, position of the player, I don't know, they could be at like 10, 20, 30, 20, 30, 40, 50. Could be at like X equals 30, Y equals 50, and Z, which is elevation, is also their 30 units above sea level. Okay. You guys understand the terminology here? So if we write it this way, then this means the car's location, it's X, it is 10 centimeters to the right of the world origin. In the X direction, it's 20 centimeters north of the world origin. In the Y direction, and it's 30 centimeters up from the world origin in the Z direction. Does this terminology make sense? And so the pedestrian here is a little bit further east and a little bit further north but it's at the same altitude. X, Y, Z, 3D directions. Yeah, it's like when you have Unreal Engine open. Like you can see the position, it has X, Y, Z. X is red, Y is green, Z, right? Z is blue. You can edit the numbers directly if you want. So this is how we write it in linear algebra. So what kinds of things can we do with a vector 3 like this? Well, we can add them and we can subtract them. That's a pretty basic thing. And so one of the most basic things to do is actually to difference two positions. And so there's something called a displacement. The displacement vector is just done by subtracting two vectors from each other. So if you want to get P2 minus P1, how do we do the math? How do we subtract two vectors? So things we know in vectors, we can do addition, we can do subtraction, we can do dot product, and we do cross product, which are both between two vectors. These are the four things we typically do with them. And these are both kind of multiplication. So I'm not just going to write multiplication. Okay, so subtraction tells you how far, so the displacement vector is in English, how far and in what direction is P2 from P1. And we do the algebra like this. You take the x components and you subtract them. 30 minus 10. Hit my thumb. 30 minus 10. And the y components, 50 minus 20. And the z components, 30 minus 30. So what is 30 minus 10, everyone? What is 50 minus 20? 30. What is 30 minus 30? 0. Okay. So what this tells us is that the pedestrian, in English, the pedestrian is 20 units right and 30 units north. I don't want to say up because z is up. It's 20 units east, let's say. So it's 20 units east. Do you guys see that? So all you have to do to subtract two vectors is you take 30 and subtract 10, and 50, subtract 20, 30, subtract 30. That's it. I told you guys, if you can do arithmetic, if you can do subtraction, you're just doing subtraction 3 times. That's it. If you can do subtraction, you can do subtraction 3 times, and now you're doing linear algebra. Linear algebra is just doing arithmetic more than once. That's pretty much all it is. So, and if you look at our illustration up here, like, you can see that person 2 is to the east and north of the car. Okay? Does that make sense to you? So the displacement vector is kind of like this vector here. So this is the displacement vector. Make the pen a little bit thinner. So the displacement vector is that vector there, starting at P1, pointing at P2. And that tells us the direction and the distance that the pedestrian is from the car. Get the general idea, but need to study it more. Okay, let's do vector addition then. So let's say that we've got, so this is called vector subtraction, right here. Let's put this in red. Vector subtraction is useful for finding out how far away two things are from each other. That's what we use vector subtraction for a lot. Vector addition. There's a lot of uses for vector addition. What if we have our position? Switch back to the Galaxy font. Let's say we've got our position here, and it's set equal to x is equal to 10, y is equal to 20, z is equal to 30. And then we've got a velocity. And this is like per frame velocity, just to make life simple on us. And so our velocity is we're going to move, we're moving northeast, right? Because we're this car, and we're moving at a 45-degree angle. So let's say that we're moving northeast at 2 units northeast, 2 units north, 2 units east per frame. So what you can do is you can say, if you have your physics engine, physics is position is equal to position plus velocity, right? Velocity is the change in position over time. It's how fast you're moving in a certain direction. In this case, we're moving 2 units per frame. I don't want to deal with time units right now, it's just per frame. So 2 units per frame east, 2 units per frame north. And so we set our position. Every frame, we're going to run the physics on this. Every frame, our new position is equal to our old position plus the velocity. So if our old position was 10, 20, 30, and we move 2 units east and 2 units north, what do you think our new coordinate is going to be? This is the x, this is y, this is z. So we're moving 2 east and we're moving 2 north. We're saying P1 is equal to P1 plus V. What do you anticipate our new position is going to be? Highly advanced math there. It's adding numbers. If you can add a number, you can add 3 numbers. That's all linear algebra is. Yep. So addition is the same as subtraction, except instead of subtracting the numbers, you add them. Yeah, very good. So our new thing, if this is P1 and that's V, then our new P1 is going to be equal to 10, 20, 30 plus 2, 2, 0, which equals 12, 22, 30. Make sense? We were at 10, 20, we moved 2 east, we're at 12, we're at 20, we moved 2 north, we're at 22. Okay. Should be pretty straightforward, I think. Right? So every frame, the physics engine is going to be doing something like this. So every frame, it's going to move our car 2 units. Normally, it would be velocities held in like meters per second, and then you have to normalize based on delta time, and yeah, you don't need to worry about that because this is velocity per frame, which just makes life easy. Okay, we've already done all the math. Okay, so prior to this frame running, we're at 10, 20, 30. We move 2, 2. We're now at this. So that's vector addition. And you can also do vector addition if you want to like let's say you've got let's say you want to shoot something, and so you've got your position here, and then you've got a displacement vector to like some gun that you've got mounted on the front of your car, and you want the bolts to come out of here. What you can do if you want to get this location here is you take the location of the car and you add the displacement vector to it. It's like this one is world coordinates. It's like north 2 east 0.1 or something. And so you just add the displacement vector to the gun turret from your origin here, and then that will give you the location where bullets should come out. So if you add 2 vectors together, sometimes they'll draw it like this. If you add this vector and this vector, they will draw it like this. So the answer is this. And so you can actually put the 2 vectors tip to tip. So if you're adding this vector and this vector, you can sort of visualize it as putting the end of this vector here or the end of this vector here. You just literally add the 2 vectors together graphically, and then that will tell you what the answer is. Does that kind of help? Like x, y. So if you have a vector that's pointed to east and a vector that's pointed to north, you put the end of one to the tip of the other one, and you get 2, 2, right? 2, 0, 0, 2. If you put them together, you get 2, 2. And you can do it either way. So you either put the end of this one to this one's tip, or the end of this one to this one's tip. Either way, when you add them together, you get 2, 2, or you can just add the components together like we did down there. 0 plus 2 is 2, 2 plus 0 is 2. Either way. There's a lot of different ways of thinking about the same thing. Vector addition, very, very useful stuff. So the rule for vector addition is this. x1, y1, z1 plus x2, y2, z2. If you add them together, you end up getting x1 plus x2, y1 plus y2, z1 plus z2. That's the rule for addition. Subtraction's the same, except the pluses turn into minuses. Okay. If I give you guys a quiz on this, would you be able to add two vectors together? Do you think? Let's do a test. Ready for a test? If you add the vector 1, 2, 3 to 10, 10, 10, what's the result? That'll be your quiz for the day. Or this will be the kind of thing that'll be on the quiz for today. Highly advanced mathematics. The final math class we offer at our college here. Only people that have taken calculus and differential equations are qualified to do arithmetic like this. Yeah, it's 11, 12, 13. Okay, so that's That's the answer. And if this was subtraction instead, if we did subtraction instead, what is the answer? Remember negative numbers. 1 minus 10, it's not 9. IS-50 Math Edition, yeah. Yeah, no, I would teach this and then half the class would drop. So, I don't know. It's not 987. It's negative numbers. 1 minus 10 is negative 9. Yeah. Yep, it happens. It happens. We all do it. Yeah, so the answer here would be negative 9, negative 8, negative 7. That's it. That's all it is. All right, so now let's do, we've done dot product before, but we'll go over that again, and then we'll do cross product. So dot product, is drawn with a little circle like that. So it's called a dot product. You might see this sometimes used for multiplication. There's probably a reason for that, because it is multiplication kind of. So the answer of this is not actually a vector. If you dot product, you take a vector times a vector and you get a scalar. What is a scalar? A number. Math people like coming up with terminology that is like super complicated. What is a scalar? It's a number. What's a vector? Multiple numbers. Scalar means it's one number. So when you do dot product, you're going to multiply two vectors times each other and you get a single scalar value as the result. And so the way we do this is x1 times x2 . Is it plus or minus? Plus y1, y2 plus z1, z2. Let me just double check that real fast. Well, I'll give you an example. So to try and work out z2. I always get the cross. There's two cross products also, and I always get them backwards. So 1, 2, 3 dot product with 2, 4, 6. So this one's going to have 3 multiplies and 2 adds. Yeah, it's not graphing. It's just computation, just arithmetic. My daughter was looking at this and she's like, "How is this college math, Daddy?" I'm like, it's it's too complicated for you to possibly understand. She's like, "I'm in 3rd grade. I can do addition, multiplication." I'm like, this is the final math class in college. And she's like, "You mess with me?" Nope. No, ma'am, I am not. Yeah, it's addition. This is not addition. This is dot product. So dot product is not going to give a vector. You're going to get a single number out. You're not getting a vector. You're getting a single number, like 5 or something like that. Anyone? length is another very important thing to do as well. I guess I'll make the pen fatter again. These are the operations we do between two vectors. And there's actually two different cross products. Version 1, version 2. Okay, so just got here in your head sorting. So algebra time. X1 times x2 is what? What is 1 times 2? Oh, OneNote. Why are you so terrible? Come on. Come on. I have to reboot OneNote again because it's a stupid product. Okay. So x1 is 1. x2 is 2. So it's 1 times 2 plus 2 times 4 plus 3 times 6. What you got? You sticky notes? Yeah. I mean, I kind of like OneNote, and it integrates kind of nicely with everything, but the fact that the thing just bugs out after an hour, you can't select different things on the palette. It's bizarre to me. 1 times 2 plus 2 times 4 plus 3 times 6. That's a dot in there. It's not 36. It's not 36. It's 3 times 6. For those of you that were coming with the big numbers there, it's 18. Multiply first, then add. Yes. Please excuse my dear Aunt Sally. Order of operations. So what we got here is 10 plus 18, which is 28. Okay? So the dot product of these two numbers is 28. Now, what is the meaning of that? What do you do with the dot product? Well, what we talked about earlier was dot product in English is how much are these vectors pointed the same way. And normally we do this with normalized vectors. So normally these vectors have a length of 1. So for example, we'll have 1, 0, 0, dot producted with 0, 1, 0. And that will give us what? If we have a vector of length 1, then the answer we get here will always be normalized as well. Or it won't be of length 1, but it'll give us a number from -1 to +1. -1 means pointed in opposite directions. Zero means perpendicular. So if we get a dot product of 0, that means the two vectors are pointed at right angles to each other. And if we get a 1, that means they are pointed the same way. You can read my handwriting. We talked about this before. How much are these vectors pointed the same way? What you do is you normalize the vectors. So in Unreal Engine, if you want to know if you're looking the same direction as an AI, you take your look vector. It might be normalized already, which means it's a unit vector. It's a centimeter pointing in the direction you're looking. You take the guard, the direction it's looking, and if you hit it with a melee attack, you dot producted it. And if you get a value above 0.6 or 0.7, it's a backstab because you hit him in the back. Okay? So the dot product of this 0, 1, 0, 0 with 0, 1, 0, 1, 0 is what? I'm going to make my zeros. They kind of look like 3s. Huh? 0. Okay. What is the dot product of this vector and this vector? You can do the algebra. 1 times 0 is 0, plus 0 times 1 is 0, plus 0 times 0 is 0. It's 0. Or you can just look at the fact that this is a right angle. If something is a right angle, the dot product is going to be 0. So the dot product tells us that these two vectors are at right angles to each other. Okay? And this is very, very useful in video games. One of the core tools in your toolbox. Am I looking at the door? You know, if I collide with the door, is the door in front of me? Yeah, because I could back into a door. You know what I mean? Like if you reverse into a door, maybe you don't have your character do the door opening animation. Makes sense, because it would look really weird. Because you can, the S key on your keyboard exists. You can walk backwards into a door, and then when you hit it, maybe by default you play a door animation, or if it's Red Dead, you smash through the door. But it'd be really weird if you walked into a door backwards and your character played the animation forwards. You know what I mean? It's the only time math will be cool is when it has something to do with games. Yeah, like all of these things, like, you know, you can talk about dot products in a lot of different ways, but I like video games. You can also use it for casting shadows. If you have a vector and a vector, the dot product is going to be this. It's going to be how far along this vector is. That's the dot product also. So if you have vector 1 and vector 2, this length here, that distance, is v1 dot v2. So if you're casting shadows, right, you have a shadow up here, or you have a sun or something, where does the shadow hit? Okay. That's the ground, that's the sun, that's where the shadow hits. There's just a huge number of, you know, it's a projection. It's what it's called in math. Math is cool in programming too. Yeah, technically the dot product is also the length of vector 1 times the length of vector 2 times the cosine of the theta between them. So that's another way you can write the dot product. A lot of different ways of understanding it, a lot of different uses for it. My main concern is this. How much are the vectors pointed the same way? That is a great tool to have when you're making video games. Make sense? You got a bunch of spaceships out in space. Hey, are they all pointed the same way? You know, you dot product this spaceship and this, like maybe you're trying to put them into a formation or something, like they need to gather up into like a little space formation or something. You'd be like, dot product the direction they're looking, and just figure out if they're all looking in the same general direction right now. You know? Dot product. Are they looking the same way? Roughly. You know, and if they're not, then, you know, if half your spaceships are pointed one way and half of them are pointed the other way, then when maybe it's a real-time strategy game and you give a command to attack, maybe they first have to sort of reform the formation, right? Where like the ones that are pointed this way have to like spin around and get into formation, then they move together to attack. That's pretty common. It's pretty common for formation-based real-time strategy games to do like when you move, like all the units like sort of get into the right place and then they move together as a formation. Make sense? Okay. Now for cross product, there's, like I said, there's two different cross products. Maybe I'll show vector length first, just because that's a little bit easier. So next thing you need to learn is vector length. All of these things have nodes in Unreal Engine. So when I was making my game engine, I had to do all of this stuff in code. I had to code all of these things, and if I screwed up any of these things, then everything got screwed up. You know, I had to make my own vector addition, and my own vector subtraction, and dot product, and cross product, and vector length. Unreal Engine has nodes for all of these things. If you want to do dot product, you just take a vector and feed them into a dot product, and it gives you the number that's the result. Okay. Same thing for vector length. If you have a vector length node, you just put a vector into it, and it tells you how long it is. And there's also vector normalize, which we'll have to talk about maybe next time. I don't know. Okay, so if you have a vector, and the vector is, let's just say it's a two-dimensional vector. So the vector has a length of 3 in the x direction and a length of 4 in the y direction. The vector length, let's call this guy v, the vector length, which we write like this, that's an absolute value sign, is going to be what? How long is v? We know that it is a triangle, essentially. It's a right triangle, where one edge of the one side is a 3, one side is a 4, and we're trying to figure out the size of the hypotenuse. Anyone know? How do we figure out the size of a hypotenuse of a right triangle? It's not 7. It's not 25. So the Pythagorean theorem is x squared plus y squared square root. So that is the length of a vector. Length of a vector is its x component squared added to its y component squared, square rooted. Okay. Old Pythagoras. Yeah, I'll just leave it in red ink, I guess. I've been doing red for the important stuff, but whatever. So, let me give you one. So if I give you a vector whose x component is 30, whose y component is 40, the length of this vector is what? So if you're asking what is the 3D Pythagorean theorem? If you have a like 3, 4, 0, the length of this, the 3D version of the Pythagorean theorem, length of this vector is the square root of 3 squared plus the square root of 4 squared plus, it's 3 squared plus 4 squared plus 0 squared square rooted. So you just add the z. That's the 3D version. So the length of this vector can't be 700, because then you'd have a triangle whose side is 30, whose side is 40, and whose hypotenuse is 700. So it's going to be x squared plus y squared square rooted. So it's 90 plus 160 is 250. Square root of 250 is 50. No, is it? Yeah. Make me second guess myself here. Okay. So this is a triangle whose leg is 30, whose leg is 40, and we're trying to get the length of this vector here. And the length is 50. So this is vector length. How long is a vector? How long is the vector? And this is very useful for like displacement vectors. Like if you take a displacement vector and get the vector length, you know, if we're coming back to our example up here of having a person in a car, if we take the length of the displacement vector is P2 minus P1. You just subtract the position of the person or the NPC and the position of the car, you subtract them. That gives you the displacement vector, which has the direction and the distance to the target. And so vector length gives you the distance. And if you normalize it, that gives you the direction. And so what we can do is we can have the pedestrian say, if the car is more than 100 yards away, don't react, no matter what. You know what I mean? Like, yeah. It would be very odd if you're like driving down the street and there's people like, you know, like normally there's sort of a max radius within which they will pay attention to you, right? You guys understand? So the vector length of the displacement vector will tell you how far apart two things are. Vector length of a displacement vector and the displacement vector can be p2 minus p1 tells you how far apart p2 and p1 are. Okay. So p2 is position 2, it's the position of the NPC, p1 is the position of the car. If you take the vector length of that displacement vector, which you get by subtracting them, it tells you how far apart the two of them are. It's mostly for distance calculations. It's used for a lot of things. Like if you take the vector length of your velocity, that tells you your speed. Right? So if we have a velocity and it's 100 in the x direction, 100 in the y direction, and 0 in the z direction, the vector length of this velocity is your speed. That's your airspeed, how fast you're traveling. And it is the square root of 100 squared plus 100 squared, which is calculator time. It should be 144, I think, if I'm doing the math right in my head. Let's just type it out. 100 squared plus square rooted 141, sorry. So the speed is equal to 141. Make sense? Vectors are direction and magnitude. You get the magnitude by doing vector length. One of the most important things about a vector. Okay. And you get the direction by doing normalization. So I guess we can talk about normalization, although in order to talk about normalization, we have to talk about scaling, which we haven't done yet. So let's do cross product first. So today we're talking about vector times vector stuff. So there's two different things called cross product. There is the scalar cross. And the good news is, like when you're doing video games, you don't need to actually do the algebra. You just take your velocity and connect it to a node that says vector length, and there's your speed. You don't actually have to do it in your head. You know, the game system will do it for you. It's nice. But you have to understand what you're doing. You guys understand? Like you have to understand that, like you have to understand in English, like, what am I doing? When I get the length of a velocity, what am I getting? Why am I doing this? Why do I need to know how long my velocity vector is? And the answer is, like, maybe the game has a cop, and the cop is going to activate and chase you if your speed is over 55 miles an hour, right? So you take, you know, there's an AI for a cop, and he looks at the player, and there's a velocity. You do vector length on it. If the vector length is greater than 55 miles an hour, then the cop turns the sirens on, begins pursuit. These are all the tools that you use in your toolbox over and over and over again to build video games. Okay. So yeah, the English is the most important part, right? What you're doing, why you're doing it. Okay. The actual computation of this stuff, the game engine will do it for you. Okay, so the scalar cross product. So the scalar cross product if you have a 2D vector is equal to x1, y2 minus x2 minus x2, y1. Okay. Scalar cross product is maximized when you have vector 1 this way, vector 2 this way. This will give you the max cross product. So what is the minimum then? The minimum is when they're facing the same way. Okay. So if these two vectors are exactly the same, if for example we cross product 10, 0 with 10, 0, we end up getting 0 minus 0 is 0. If you have identical vectors, and we can make these not zeros to make them a little more interesting, 10 times 10, 2, 10, 2, then x1, 10, y2, 2, 20 minus 20 equals 0. If you have vector 1 and vector 2 pointed the same way, then the cross product equals 0. It's the opposite of dot product, or it's a 90-degree rotation of dot product. It's one way you can think about it. Okay. So sometimes they will use cross product for backstab. You can cross product two vectors, and if you get a value that is close to 0, that means you're kind of pointed, in the same direction. So you can technically use it for that. But here's the thing. Cross product is mostly used in English. In English terms, we use cross product to determine is something to my right or left. Okay? So let's say that we've got, a car driving towards a pedestrian. The pedestrian needs to know, should I jump to my right or should I jump to my left? Right? Cross product. Dot product doesn't help you. Dot product will give you 0 for either to the right or the left. It doesn't help you determine which way you should go. For cross product, if we have vector 1 here, and then vector 2 is over here to the left of it, then you will get, let's see, 0 and 0.7, 0.7. You will get 0.7 minus 0. Yeah, so to the left is positive, and to the right is negative. Okay. So we'll get a positive number if the thing you're looking at is to your left. You'll get a negative number if the thing you're looking at is to your right. And it just depends which one is V1 and which one is V2. If you switch which one is U and which one's the displacement vector to your target, then obviously the signs will flip, so you shouldn't read too much into it. Okay. Week's worth of math. It's all just arithmetic. Multiply, minus, multiply. That's it. What matters is not the computation. Again, it's the knowledge. Is something to my right or left? So if you've got V1 cross product V2, a negative number means V2 is to the left. A positive result means V2 is to the right. Make sense? So now we're kind of catching up on our case up here. Should the person jump right or should the person jump left? Well, we've got the velocity here of the car. The velocity of the car is v1. And then we've got the displacement vector pointing to the player. Okay. So is the player to the right of the direction the car is moving, or is it to the left? We might need to normalize. Let's see. Should probably normalize these down to unit vectors, but either way. So are we going to get a positive number or a negative number if we do this? If we say v1 cross product with the displacement vector. This is the displacement vector here. Are we going to get a positive number or a negative number? Negative. Yeah, negative numbers are to the right, positive numbers are to the left. So when we have the AI takes the direction that the car is moving, and it does some sort of computation to figure out if it's kind of within a dot product cone of the thing, right? So the car is kind of moving this way, and there's like probably some cone that the character wants to not be in, right? And so once it determines it's in the danger zone, then it needs to decide, do I jump in front of the car or to jump away from the car? Well, how do I figure out which way I jump? Well, do this. You take the velocity, you cross product it with the displacement vector. The displacement vector, again, is just p2 minus p1. And you normalize both those values to get a unit vector. So you have a unit vector pointing the direction the car is moving, unit vector pointing towards the player, and if you get a negative number, that means you're to the right, and so you jump laterally. You create a vector perpendicular to the velocity, like this, and you jump that way. If you're on the other side of the car, you jump that way. And so the person will jump at a 90-degree angle to the velocity of the car. And they jump out of the way rather than in the way. And there you go. The whole Spraggins family is watching. They're getting highly advanced mathematics right now. Highly advanced. I don't know if your family is ready to add 3 numbers all at once. 10 plus 30, 20 plus 50, and 30 plus 30. If you add these 2 vectors, it's 3 adds you have to do. Highly advanced mathematics. Okay. So that's one version of the cross product. One version of the cross product is called scalar cross product, and it just gives you a number from -1 to +1. -1 means -1 is all the way to the right, +1 is all the way to the left, 0 ahead, 0 behind. Okay. That's the scalar cross product. Then there's what's called the vector cross product, which scalar cross product, and then there is the vector cross product, which returns x. Like, let's say you have a vector pointed down the x direction, a vector pointed down the y direction. The scalar cross product, the vector cross product will, if you put in x and you cross product it with y, it'll give you z. It gives you a vector at a 90-degree angle to both of the vectors you pass in, essentially. So this is very useful if you have, I don't know, like a triangle, like a triangle, like computer games are made out of triangles, and you want to know where is the normal vector. The normal vector is a vector pointing out of the surface of something. It's always pointing outwards. So to get the normal vector, you take this leg, v1, v2, cross product, v2, and this gives you the normal. That gives you a vector pointing out of the surface. And this is used for all sorts of things, like light. Like if you have sunlight, and sunlight bounces off the surface here, it bounces around the normal vector. So whatever the input angle is the output angle. So normal vectors are used all over the place. And you make a normal vector very easily by just cross-producting the two legs of the triangle together. Yeah, so vector cross product, in plain English, give a vector at 90 degrees to the two input vectors. So these are the tools. These are the tools of the trade. There's more, but that's enough for today. So let's hop into Unreal Engine and do something with it. Let's show you how this works. You guys want to see? You want to see the cross product in action? Do you have any questions about those things? There's a lot of different things we talked about today. I kind of feel like seeing it in action might help. So what did we talk about today? We talked about addition, subtraction, dot product, cross product 1, cross product 2, and length. 6 different things today. 6 different tools for your tool chest. Far Cry 6. Has anyone played this? Is this good? I had one student telling me they thought it was pretty good. It was Spraggins, yeah. Base building survival. Oh, interesting. Base building survival. That's not been done before. RTS, kind of. Okay. Story's terrible. Action's awesome. How similar is it to like Ghost Recon or like one of those games? Because like I kind of have fun with them at first, and then after a while it's just like you're just slogging. You know, there's just so many zones and so many bosses you have to clear. In order to fight a boss, you have to clear the mini bosses under them, and you end up collecting like pigeon droppings from 50 different states across the continental United States. Like those games kind of drag on me after a while. Like, and there's some areas you can walk to, but like they're too hard if you go there. I don't know. All right. So what do we have here? Oh, I added a post-processing effect to the stage up here. So it affects the exposure of the camera and puts on a heavy vignette, and then when you leave, it wears off. So you can use that for like high altitude, you know, scenes and things like that. So we did the doorway last time, right? Yeah. Locked on. Okay. Huge map, tons of vehicles. Okay. So let's do this right and left thing. So let's make this thing here. We just want it to tell us, are you to my right, are you to my left? Pretty simple, right? What do you think? Do we have an event tick currently? No. Okay, so let's just have it every 4 seconds. It will tell us, are we to its right or to its left? Okay. The event tick. Let's make sure it's looking in the right direction. Actually, I think this guy might be looking. I think it might not be actually looking in the in the right direction. You see how the X is this way? So it's actually looking exactly backwards, I think, from where it's supposed to be. So we'll just make a new one, I guess. All right. New blueprint class. We'll make just an actor, and it'll be I don't know. Security guard or something. Just move to the right or something. I don't know. All right, so the security guard, we will add a skeletal mesh. We'll replace the scene read with it. There we go. Scary clown. Animation blueprint, animation asset. That's a little disturbing. Maybe just idle. There we go. That's perfectly creepy. Okay, so we've got a skeletal mesh, we got it idling. We need to make sure it is looking in the right direction, and it is not. It is, see how it's looking in the Y direction here? So I'm going to rotate senior. Oh, I can't rotate it. Dang. Alright. Default scene root. Skeletal mesh. Scary clown. Nope, that's paladin. Scary clown. Okay. Yeah, the art assets from Mixamo are rotated 90 degrees off center. It's kind of annoying. So let's go ahead and just rotate it 90 to the left. Now, you see how it has the X direction here? Now it's actually looking forward. And the animation blueprint will be... a little creepy. I'm getting distracted. Let's do an idle animation. We'll just do that, so we know which way it's looking. Okay. This isn't the point anyway. Okay, so what we want is just every event tick, so every delay, so every like 4 seconds or so, we want it to wake up and find the player and tell the player, are you to my right or are you to my left? Okay, pretty simple. So we'll start off by just doing this and doing print string, and we'll just start off by saying hello. That just to make sure everything's working right. Snap it to you, and we will drag out the security guard over here, and so yeah, there we go. Okay, so okay, it's currently printing hello a bunch of times. This is maybe not have him be on the stairs or something. Okay. So we want it to say, are you to my left, are you to my right? Okay. So we want to get our look vector. So we want to get forward. That's actually not a thing that we need there. Get forward vector. So we're going to get the forward vector for the skeletal mesh. Get the forward vector. And so what we want to do is we have the direction the person's looking. And if we want to know if the player is off to the left or right, we have to do the displacement vector. So the displacement vector is going to be get player 0. So that's the player. And we want to know their location. And we want to get our location. So a displacement vector is caused by subtracting P2 minus P1. You're not going to fail the class, Fragons. Don't panic. I don't run this class like a CSI class. All that matters is just getting the work done. At worst, you'll fail one of the assignments. Not a big deal. Okay, so this is the displacement vector. So this will compute displacement vector from clown to player. So this gives us a vector pointing at the player from the clown. And we probably want to... There's two things we can do with this. We can get vector length. So vector length is how far they are away. And the other question is direction. No, sorry. Normalize. Every vector is two things. It is both magnitude and direction, right? And so this is the magnitude, how far away they are, and this is the direction. It's a unit vector now that it's been normalized. It's a unit vector pointing at the direction of the player. Now we've got now that we've got the direction of the player and we've got how far away they are, first thing we should do actually is probably print these values out, but we got 10 minutes left, so we'll just move forward. Yeah, if you remove meshes, then it breaks your event graph and things like that as well. Yeah. What I would do is, there's a lot of things to do, but don't worry too much about it. Okay, so we've got the direction of the player, we got the direction we're looking. And we want to know is the cross product. So we're going to cross product. Let's do things here. And this returns a vector. But what we want is the scalar cross product, so we get the vector length of this. That's going to give us a negative value, isn't it? Let's see. It's the z direction, positive or negative? So let's output the cross product. I think I know what to do here. Print string. So every tick, every 4 seconds, I'm going to up it to every second. So every second it's going to print out the vector of the cross product. Okay, so you can see cross product changing. I'm behind him now. It's off at 90 degrees, it looks like. It's probably because I rotated him. It's frustrating. So you see on one side it's 0. On the other side it's 0. Behind it's negative. And in front it's positive. So this is literally doing the dot product right now because the person has been rotated 90 degrees. Let's try this. No, it's giving the wrong result. Alright, so what I did was I just switched out the cross product with dot product because the model is rotated 90 degrees off. Cross product is essentially the sine and the cross product is the cosine, and so if the model is rotated 90 degrees, I just switched cross and dot. And there you go. It's doing cross product essentially. So over here we can see that when we're to the right of the security guard we get negative 0.1 or pretty close to it. And then when we're on the left side we are getting positive +1 or close to it. When we're in front, we're going to get a number close to 0. And when we're behind, we get a number close to 0. So, yeah, dot product and cross product are just a 90 degrees phase shift off from each other, essentially. Okay. So, can't find the third person event graph. It's, yeah. What's your main character? Because I called mine main character, but yours is your default thing is going to be called third person BP or something like that. Okay. Cast a HUD. When you begin playing, you create a widget of the type of your health bar. And then you add to viewport, and then you attach it to player 0. It's the first player. Is this your thing? I can barely even see that. Touch input. I don't see you attaching the widget to the screen on here. So you're going to need a begin play event, input touch, move right, move left, up, down, jump. Yeah, you're going to need to do this. And I'll just put that up on Discord for you. And our time together has come to an end. So your quiz, you're not going to have a programming assignment today. Just work on whatever you want if you want to work on anything. But I'm just going to put up a little math quiz and just see if you guys understand the math concepts. Okay. You don't need to, main HUD is just the name of my widget. So it's just called create widget. So if you go to create widget like that, then you pick what kind of widget. Okay, and it changes the name up here. The owning player is connected to player controller 0, and the result of this attaches to viewport. And there you go. So that is it for IS50B, IS50A, IS50B people. You're up in 5. Okay, I'll see you guys on Tuesday.